Hi everybody, I am Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Hi, now we are going to discuss partial molar property. It should be explained in a manner that is the thermodynamics of open system. In the introductory video of thermodynamics, we are familiar with what is a system, what is its surrounding, and what is thermodynamics. And we are familiar with some other the meaning and properties of a system. Now let us go into this partial molar property. Before going into that, we should be familiar with what is extensive and intensive property of a system. An extensive property of a system is which depends upon the amount of the substance, or substances present in the system. Examples are mass, volume, and energy. Okay, when we change the number of molecule of the system, when we change the amount of the substance, that will at constant temperature and pressure, that will change the weight of the substance. When we add something to the substance, when we add something, if there are any number of substances of the constitutive 1, 2, 3. Okay, so if we are increasing the number of moles of first chemical or number of moles of second or third chemical present in the system, or if we decrease the number of moles of the substance of the first chemical or second chemical or third chemical of a system, then there will be change in the mass of the substance, mass of the system, and volume of the system, and energy produced by the system. Definitely there will be a change. These type of properties are called extensive property. And what is intensive property? Intensive property of a system which is independent of the amount of the substance present in the system. Okay, like temperature, pressure, density, concentration, viscosity, refractive index, surface tension, like that. For example, if we find out the boiling point of pure water by taking 10 ml of the pure water, it will be 100 degrees Celsius. If we take 10 liters and finding out the boiling point of the water, then that will be the same 100 degrees Celsius. And if we take the concentration of 1 ml of the particular chemical and 1 liter of a particular chemical, that will be the same. The density also will be the same. Those properties which is independent of the amount of the substance, they are called intensive property. Okay, now we are moving into this what is the partial molar property. First we should know the meaning, partial molar property. For example, if a particular class students are contributing to a particular work, okay, so for any voluntary work, if the students of 50 members, and each and every student will be contributing towards the total work, the contribution by each and every student will be considered as the total contribution. That is what called partial molar property. But if we are considering only one student, that is what called partiality. That contribution by each and every student is called the partial molar property towards the total system. Okay, so we will clearly understand the concept when we are looking at this derivation of the system. Okay, consider a system which has the temperature T and its pressure as P. Okay, its temperature is T and pressure as P, and that system consists of any number of chemical, and the chemicals may be present in any number, different numbers. Okay, let N1, N2, N3 and so on, Nj be the respective numbers of moles of the constituents, various constituents 1, 2 and 3. If that is a binary system, then there will be only 1 and 2, first chemical, second chemical, and the number of moles of the first chemical will be termed as N1, and the number of moles of the second chemical will be N2 of the binary system. If there are more than 2 chemicals, 3 or 4, then the number of third and fourth will be termed as N3, N4 and so on. Okay, then x must be the function of temperature, pressure and the number of moles. So here x is a property and x is an extensive property. What is extensive property? Which depends upon the number of moles of the substance. So which is a function of x must be a function of temperature, pressure and number of moles. Okay, when we change the number, when we change the number of moles, when we change the pressure, when we change the temperature, definitely that will affect the total quantity. Okay, that is, this can be, what I said, can be given in an equation form. So x is a function of x is a function of temperature, pressure and number of moles of the chemicals present in the system, number of moles of the constituent, there may be any number. Okay, so when these any of these quantity changes, that will affect the total property. Okay, x, where the N1, N2, N3 can be added together, N1 plus N2 plus N3 and so on. That can be given with a symbol, new symbol N, capital N. That is called total number of moles present in the system. We can say total number of moles present in the system. Okay, when we are considering the total number, that should be indicated with the total N. Okay, for a small change in temperature, pressure and number of moles of the components, the change in property will be indicated with dx. Okay, the difference in x. Okay, simply difference in x. If we know differentiation, then this will be very helpful in understanding this derivation. Otherwise no problem, this is only simple only. Okay, dx is a difference in x, the property x will be given by the expression. Okay, how it is explained, now let us see. Dx is equal to dou x by dou t at constant pressure and number of moles into dt. What is dx and what is the difference between dx and dou x? Dx is a complete differentiation, the total, all the properties what we are going to see now. Dou x is partial differentiation. Partial means any that particular property, the property with respect to temperature. Okay, at constant pressure and number of moles. So partial change in the property x with respect to temperature at constant pressure and number of moles. Okay, that is the change in temperature, that should be indicated here. Plus dou x, the change in the change of the property x with respect to pressure at a constant temperature and number of moles into dp. Here we have dou p, so it should be indicated here dp. Plus the partial differentiation of x with respect to the number of moles of the first chemical, dou n, at constant temperature, pressure and n2, because n1 should not be here since it is changing dou n1, difference in n1. N1 is changing. So n1 cannot be a constant here. So what are all the variables we are indicating here should be a constant one. So change in the property x with respect to dou n at constant temperature, pressure, and number of moles of the second chemical, third chemical, and so on, which are all present in the system. So dn1, okay, that should be denoted here, plus and so on, plus dou x by dou n2. Here now we are considering the change in the property, change in the number of moles of the second chemical. So at constant temperature, pressure, and the constant number of moles of the first chemical, comma n2 is missing here, since n2 is with respect to the change in property with respect to n2, we are purposely missing here, and it should be noted here dn2 plus if for any, this is the one which is very important, dou x by dou ni, change in the partial differentiation of the property x with respect to any one property, dou ni. This should be mentioned here, that is dou x by dou ni. This is very important because this is a general representation with the ith equation, dou x by dou ni, with the change in the partial differentiation of property x with respect to the number of moles of the ith component at constant temperature, pressure, number of moles of other constituents other than ni, okay, plus and so on. The last one, dou x by dou nj, the last property, the last number of moles of the last chemical, dou x by dou ni at constant temperature, pressure, n1 and so on, nj minus 1 into dnj, okay, and the nj, in the case of nj, should be avoided here, okay. So before that we are stopping nj minus 1, okay, nj minus 1. So that is the equation number 2. Next we have the quantity dou x by dou ni. This is one, dou x by dou ni at constant with the change in the property x, partial differentiation of the change in the property x with respect to dou ni, that is the partial change in ni at constant temperature, pressure, n1, n2 and so on, nj, dni is called the partial molar property of the concerned component. So here the ni is the concerned, the change in the concerned component, okay. This is more often represented with xi bar, here xi bar, clear. Thus for the ith component in a system we can change it for anything, any property. Partial molar internal energy is equal to dou u by dou ni. The partial molar internal energy is indicated with u with respect to dou ni at constant temperature, pressure and number of moles of the constituent present in the system is equal to mu I bar. Here I said it is the property is generally represented with xi bar. So partial molar internal energy is represented with dou u by dou ni at constant temperature, pressure, number of moles of the constituents equal to ui bar, the partial molar internal energy. Likewise, the same equation can be indicated or written for other properties like partial molar enthalpy, dou h by dou ni at constant temperature, pressure and number of moles is equal to hi bar. So this is just the representation of the ith component in the present in the system. Likewise, partial molar entropy, dou s by dou ni at constant temperature, pressure, n1 and so on, n2, n3, si bar, and partial molar volume is equal to dou v by dou ni at constant temperature, pressure, n1, n2, n3 is equal to vi bar. In this manner we can represent the partial molar properties. Thank you.